think we can slowly start. So, good morning, good afternoon to everyone. You are very welcome to this webinar dedicated to integrated ecosystem assessment with a focus on the StrathE2E interactive tool. It is a great pleasure to moderate this session, which marks the second webinar in a series organized within the framework of the Mission Atlantic project. For those who don't know, are not aware of this project, Mission Atlantic is a project with an Atlantic dimension. It brings together researchers, technical experts, and decision makers around a common objective to improve the way we access, understand, and manage marine ecosystems in an integrated and sustainable manner. This webinar series aims primarily to present the tools developed throughout the project, which concluded last month, and to share practical experiences, results, and lessons learned. It also seeks to discuss the impact of these tools that have already had and that we hope they will continue to have on a broader scale in the future. And today, we will have the opportunity to learn about the StrathE2E interactive tool. Today's session, we will explore environmental management scenarios with the StrathE2E online app. This tool allows us to use what-if scenario experiments to explore how environmental change and management choices affect marine food webs in the Atlantic. This session intends to be a space for exchange and dialogue, so I encourage everyone to participate actively by asking questions. You can use the Q&A tool at the bottom of the your Zoom screen. And also write comments in the chat throughout the webinar. We will have a dedicated discussion moment after the two presentations that we have today. And in the meantime, I'll invite everyone to introduce yourselves in the chat, indicating where you work and from which country you are joining us. Without further ado, I'd like to thank you all for joining us today. And it's now my pleasure to introduce our first speaker, Jack Laverick. He's a Chancellor's Fellow in Statistics and Data Science at the University of Strathclyde in Scotland. And Jack is one of the developers of the StrathE2E tool and its online web application. So Jack, thank you for participating in this webinar, and the screen is yours.
Great, thanks Tanya. So thanks everybody for joining us today. It's always a bit of fun to have a chance to demonstrate the web app to a new audience. So I, rather than showing you a set of slides and doing a presentation, thought it would be a bit of fun to use the 10 minutes to actually run through a live demonstration of the app with all of you. So you can see a bit of what it does, and perhaps you feel like having a bit of a play later yourselves. All you need to do, if you'd like to follow this up later, is put inside your web browser this sort of shiny link to the StrathE2E app. It can also be easy for you to just Google StrathE2E app, and you'll find the Mission Atlantic website, and a link to this app will be on the tools page. We can also put that in the description, I think, and circulate on an email if anybody has difficulty finding it afterwards. But if you get here on your own, there's a little guided tour button. You can click here, which will take you through a tutorial explaining how you get to run your own simulations using the app. And if you want to have a bit of background on the model, you can click on the About page and we get some information here. So I'm not going to labor this too much, but I know that there are people here that might not be aware of what StrathE2E is. So the main purpose of it is to try and represent the entirety of a marine ecosystem. We're trying to look at things at the base of the food web, such as the chemistry and the physical processes that are working their way through the microbes, through the plankton, up through fish, whales, all sorts of things that we're interested at the top of the food web. And generally speaking, limited to continental shelf regions, but we do have a few oceanic island regions where we've made implementations of the model during Mission Atlantic. If you keep going down, you get a bit more of an idea of the model. So we're simplifying space and we're simplifying the representation of species in order to make the model fast. This means that we're able to do fun what-if experiments and explore elements of uncertainty. And we can also compare the results of the simulations to real-world observations to make sure that things are behaving in a way that we think is realistic. We can look at up to 12 different fishing fleets operating within an environment at the same time. So you can get conflicts between local and international fishing fleets, or looking at things such as hooks and lines or static gear on the seabed or trawling. And each of these different fisheries inside the model will be affecting the food web through taking landings, but also bycatch, discarding, and abrading the seabed, so disturbing sediments and potentially resuspending nutrient. We have a bit more information here about the different types of organism that are represented in the food web. They're brought down to what are called functional guilds or functional groups. So they're collections of species that behave in the same way. And we have the sort of top predators like our seals and our whales, through planktivorous and predatory fish, down to scavengers and filter feeders on the bottom of the seafloor, and of course the plankton, the kelp, the nutrient availability there too. We have a simplified spatial structure where rather than representing high resolution maps, we end up mapping the variability in the system onto ocean volumes. So we have the inshore, offshore, and deep volume that are modeled, so 3 compartments there, and we have 8 different shelf sea habitats. So these are types of sediment that things can live in. This kind of gives you a bit of an overview of how the model is built. We take a variety of input data, take these from large system models of projections for different places in the world, and we can represent different time periods so we can have an understanding of how climate change might proceed in different places. If you want to know any more, you can go through this page yourself and look at your own leisure at some of the extra detail there. But we also have a website for people who can code, who would like to interact directly, programmatically with the package. And we have a little bit of a list of our project history and some of the scientific publications we've done. But the beauty of having this online app is that for people who can't code, you can actually run simulations and do these sorts of what if experiments yourself. So that's what I'm going to have a quick run through of for you at the moment. This map shows all the different regions we currently have available models for StrathE2E. These are in red, and you can select them by hovering over the map or by using these drop-down menus instead. In white, you can see a few more models that are currently under development, and they're hopefully to be released soon. But we're spanning Atlantic systems going right from the bottom of the Atlantic in terms of South Africa, down to Brazil, all the way up into the Arctic, thinking the Bering Sea and east of Greenland here. As an illustration for today, I'm just going to click on the North Sea because I'm in Scotland and that's what's close to me. And this loads the initial model. And we can see that I have the North Sea here, and it's defaulted to a time period representing the 1970s through to the 1990s. I'm going to change this to something that's closer to today. So that's the early 2000s. And we'll just leave it on the standard climate change model. So if I just click this button, that's loaded the model. And what I could do is I could go and have a look at how that model's behaving. What is it suggesting is happening in the sea in terms of the fishing characteristics and in terms of the food web? But what's more fun is to go and do these what if experiments yourself. So for that, we'll go into the setup scenario section, and we're faced with a variety of options on this screen. If you have this yourself, you'll get a little tooltip that comes out when you hover over the button. In my experience, that doesn't show when you're sharing your screen. So to just tell you the kind of options, the type of scenarios we have. We've got climate change scenarios. We've got nutrient input scenarios here. We've got changes to fishing activity, changes to seabed abrasion, changes to non-lethal effects in the food web. So that's things such as pollution or plastic litter. We have additional sources of mortality. So you could think of that like a disease outbreak or some sort of lethal toxic event. We have changes to fisheries discarding, and we have changes to the spatial distribution of fishing. There's more that you can do if you're a programmer, but this is the interface that allows somebody who's perhaps more of a stakeholder and not a technical scientist background to be able to interact with the model themselves. So let's do an example today where we change some of the fishing activity in the North Sea. Here are the activity rates as sliders for the 12 different fishing fleets that are operating in our model. And I'm just going to look at 3 of these trawling fleets. So these are our pelagic trawls and sens, and I'm going to set the activity to 0. I could double it if I wanted a different scenario, but going from a multiplier of 1 to 0 turns it off. I'm going to do the same thing here, and I'm going to turn off the sand eel and sprat trawls, and I'm also going to turn off the beam trawls that operate in the North Sea. If I now go back here to run the scenario, you'll see that this button's gone red. That's telling me that I've made a change from the baseline scenario. And I'll now run the model for 5 years just to see what happens now that I've made a change in the system. So this is running the model in real time back at Strathclyde on a server. So there's no pre-rendered outputs. This is just how quick our model is to simulate things. And we can now go into the results center and see what we've done to the environment. So up here, we have the option to see what those baseline results would have been. So what's happening in the early 2000s before I made any changes. And in the inputs, we can see things such as the habitat map, but also what's happening in terms of the environmental drivers. So things such as temperature changes or nutrient concentrations over the course of the year. We also have plots that describe the amount of mass across different parts of the food web. And we also have a fisheries plots section here, which tells us a little bit about how much fish is being caught by different fishing fleets inside the system. And we can change this from the rather obscure millimoles of nitrogen per meter squared unit that the scientists use to the live weight in thousands of tons. And you can see how pelagic trawl sens and the sand eel sprat are catching all of the planktivorous fish that we catch. And most of that is happening in the offshore zone with very little discarding. If we come back, we can have a look at what happens in our scenario where I turned off those particular fisheries and said that they weren't allowed to fish anymore. So if we look at the fisheries effects, we now have what we refer to as a tornado plot. And we can see here that green lines show parts of the fishery where we're catching more than we were before. And this is in percentage change. And red lines are showing where we're catching less than we did before. So by turning off those fishing vessels, we're catching almost zero planktivorous fish, almost zero migratory fish, and a bit less of the demersal fish. But interestingly, we're catching more of the cetaceans, and that represents a bycatch effect. If we look at the discarding, we're also throwing away less fish because we're not fishing as much, but we're also now discarding more whales than we did before, which might seem strange. But if we come back and look at the ecological effects of what's happening in the food web instead of to the fishery, this gives us our explanation. So by turning off those fishing vessels, what's now happening is we've got more planktivorous fish in the system. There's more biomass in the food web, and this causes a trophic cascade. We have more cetaceans, more whales, more birds, more seals because they now have more food to eat. And it's because we have an increase in their mass that we're now seeing increased bycatch of whales in the fishing fleet because there are more whales about. So there's a greater risk that a fishing boat will accidentally catch them. What we're also seeing is a reduction in the zooplankton in the food web, and that's because this increased biomass in the fish has led to an increased predation on that zooplankton layer, and this cascades through the lower portions of the food web, and we're kind of having that classic mid-controlled effect on the food web in the North Sea that's being mediated by our actions as humans on the planktivorous fish as a fishery. Now you can kind of go back to the scenario and you can make a whole bunch of different things. You can change things all at once. You can put more fishing, you can do less fishing. You can see what happens under different climate periods as you change fishing. But that's the kind of exploration that I'm going to leave you to do for yourself because that's half the fun of having an interactive app like this. So you don't need me to do it all for you. And hopefully you can see a place for this yourself, where perhaps in workshop settings with stakeholders and things, rather than relying on scientists to pre-generate some reports and a set of results, you can instead sit together and play games in the app by moving sliders up and down and seeing if the environment you produce is something that you both find acceptable. So there we are. Thank you very much.
Thank you, Jack. Thank you very much for going through the app. As I said, all the questions we will address them at the end of the two presentations. Please feel free to comment and to ask questions in the Q&A icon. And now we'll go to our second presentation. Our second speaker is Nana Obem. He's a conservation scientist and wetland manager with the Wildlife Division of Ghana's Forestry Commission, where he oversees the Sakumu and Densu Delta Ramsar sites. And his presentation is going to be on applying the StrathE2E to coastal wetland management, insights from the Sakumu and Densu Delta. So, Nana, the screen is yours.
Hello, good afternoon to everyone. hello, good afternoon to everyone. Yeah, hello, good afternoon to everyone. Please, can you hear me?
Yep, we can
Yes.
hear you. We can see your screen now. That's all great.
Okay, can see the screen now? Okay. So, as said by the host, I'm presenting on applying StrathE2E to coastal wetlands management. Our insight from the Sakumono in these Ramsar sites. As Dr. Jack said, the software is supposed to help for us to look at the biomasses and things. And the wetlands or the Ramsar sites are also connected one way or the other to what happens within the bigger oceans. So this is what insights we have within the Sakumono and the Ramsar sites. So I'm going to present within the 10 minutes. These are what we are going to look at, and I'll show an appreciation as well. So my name is Nano Binyudwije. I work with the Wildlife Division of the Forestry Commission, the Wetlands Unit to be specific. I hold an MPhil in Integrated Coastal Zone Management, where my research looked into livelihood vulnerability within the selected coastal communities of Ghana. I also have a project management to help me coordinate and improve projects within the wetlands and coastal environment. Ideally, within the 21st century, the role of a wetlands manager or management should be on biodiversity monitoring, supporting restoration and nature-based solution, managing human pressure, and also advising stakeholders and local authorities. But currently, due to the lack of data to integrate science with science-informed policy, um, this has brought about an ineffective interventions within those things. Making the wise use concept, which was signed under the ransom conventions, very necessary, or making the concept being good, which it has brought about uncertainty under competing pressures and making management decisions difficult. Why tools like StrathE2E are needed? We all know that our coastal wetlands that we manage are highly dynamic ecosystem. They are strongly influenced by the climate variability, hydrological changes, and human activities. And also within where we are, most of the information that we get are from folk tales from our locals and Earth observation monitors. However, because of this, and because of our coastal wetlands being very dynamic, data that we get from the folk tales and the Earth observations are fragmented. They are also limited to time and space and insufficient in predicting our ecosystem responses. This has created a management issue. Hence, we need there's a need for a what if to for decision support to guide changing management decision and to help managers anticipate the possible future outcomes. Here are some negative scenarios that are currently within the Sakumono Ramsar site, which includes the encroachment situations that you can see, and also plastic waste. Also for the Densu Delta, we have encroachment situation, and also people harvesting the mangroves that has been grown for a type of fishing called the Atija fishing. On the positive scenarios that we can look at, a lot of restoration project has gone on within the Sakumono Ramsar site, which has brought about a lot of mangroves being restored and also tree crops. Also, the research from students are engaging in a lot of research, and per the data we have now, the bird species have also increased, or there are a lot of bird species. So that means the Ramsar site is still working or functioning as such. With respect to the Densu Delta, The red mangroves are also growing well. There's a lot of research going on, and also with places like uh, with salt mining also actively going on, and the women also have oyster fishing that they are doing, and there is a forest within the site that houses monkeys and other reptiles as well. Applying the Strat E2E to Sacramento and Densu Delta for scenarios like the development around the Ramsar boundaries. It can also help us predict the habitat loss, decline in ecosystem service, and the long-term ecosystem degradation pathway. This will help management with interventions such as strengthening the zoning and buffer zones, then also support environmental impact assessments that are being done, and also communicate further risks to planners and policymakers on the inflows of fresh water and seawater. The two can help with changes in the lagoon salinity, also impact on fisheries, and also effect on bird feeding and breeding areas. This will help management with discussion on water management, also support environmental flood advocacy, and also guide restoration timings and set priorities on which one should be done. Why the scenario model matters for management. It will help for the ecosystem to remain resilient under the changing environment condition. It will also help management to visualize the possible future of our current ecosystem, allowing for the selection of a concrete approach option such as the restoration design, management planning, and adapting climate realistic strategy, making anticipatory management and evidence-based decisions. The benefits that this Strat E2E will give to the Sacramento and Dane society is that the Strat E2E will provide a practical way to explore future scenarios before irreversible changes occur within the sites. This will also help the site to have proactive management, strong policy engagement, and long-term ecosystem resilience. The two will improve decision making through a science-based scenario planning for sustainable wetlands management. Thank you all for your time and your audience, and thank you for your commitment to sustainable ecosystem management. Thank you.
Thank you, Nana. Thank you so much for giving us an example um, on a what if scenario for the wetlands in Ghana. So I see that we had one question, but it was answered. It was by Luis Fernandez asking whether there will be some data for the Western Atlantic for them to play with. And it seems that we would need to find, well, Jack, will need to find the next grant opportunity. But it seems that there could be already some partnership between Jack and Luis Fernandez.
Depends on who you get access to, but we've had master's students who have been able to build StrathE2E model implementations within 6 months, perhaps a year, depending on what the data availability is like for different systems. We have access to Earth system model outputs for the whole of the Atlantics. The Northwest Atlantic is something that's relatively straightforward to do, particularly depending on which part of the coast you choose. The fact that there is some quite good monitoring data that's coming out from that part of the world. When we work in regions such as Greenland, where there's a bit less data collection going on because there are limits in terms of access for ice, it can become quite tricky to be able to collect the information we need to build these new models. Mission Atlantic itself focused a bit more on that eastern side of the Atlantic because it was funded by the European Commission. And I imagine that there's probably NSF related funds perhaps that would be accessible for working off the coast of the Americas maybe. But that's the sort of thing that we're always open into looking into, is finding, is this something that works for someone in their PhD? Is it a master's project, or is it part of a bigger grant where we try to collect together some new data collection and stakeholder engagement with the production of a new model And that's what we did in Mission Atlantic, tried to incorporate StrathE2E within that integrated ecosystem assessment framework as a management strategy evaluation tool. So it was one component of a larger process of looking into the health of that part of the world.
Thanks, Jack. And for people who would like to connect with you, uh, I don't know if your contact is on the StrathE2E app.
There's a contact, I think, at the bottom of the landing page. I think that takes you to the professor, Mike
Oh,
Keith,
yeah,
but he'll also just fire you
I
over
got
to me
it.
as well. So you can either Google my name and find my email if it wasn't already circulated as part of this webinar. But as long as you Google StrathE2E, you'll find somebody in the department and we'll be able to have a chat.
Okay, thanks, Jack. We had another question, but it's from Irene Martins, whether they can use the app for teaching purposes. Of course.
Yeah. I mean, can you be more specific, Irene? Are there sorts of things that you'd like to use the model to teach? You can use it as part of fisheries management ideas because you can use StrathE2E to try and investigate things such as maximum sustainable yield by conducting experiments where you modify the amount of fishing pressure and look for that nonlinearity. Or you can be looking at it as a tool for teaching ecosystem food web scale modeling and looking at network theory, that sort of stuff, or climate change impacts on food webs. It's the fun thing about end-to-end ecosystem models is the number of questions you can ask are loads. Cool. Nice to see that there's ecological modeling and a bit of fisheries stuff for Louise. That's all really cool. Yeah, and if you want to in any way have support in knowing how to interact with the model, whether you want to use it in the app or whether you have students who are coding in R and would instead like to do projects where you can do this programmatically, then I'm very happy to have a quick chat about that as well to get you set up. We have an online
Right.
training course with the R code, so you can actually copy parts of the code to run things yourself on a laptop. It's not a heavyweight model that requires a supercomputer. It's designed to run on personal computing resources.
Yeah, great. Thanks, Jack. And now we have a question as well. Uh, could you unpack some of the specific policy implications of the app? How has the uptake been amongst policymakers? It's one thing to see what happens under different scenarios, but a different thing to decide how to mitigate and safeguard in broader terms.
Yeah, that's definitely true. We've had some engagement with stakeholders, but we're not yet at the stage where there's been specific this policy was implemented because of something that StrathE2E has said. One of the more high profile cases we had was about 10 years ago, back when there was discussion about the fisheries discard ban back in the EU, in EU waters. We ended up generating a report there investigating what the impacts would be on banning discarding. And that formed part of the conversation. I'm not going to claim it was the single driving factor of what happened, but what's interesting is that if you take a food web perspective, discards just go back into the ecosystem and then get recycled as a nutrient if you're looking at it from a steady state perspective. If you end up forcing the landing of discards, then that's a extraction of the nutrient from the system that then going towards land. So there was a lot of public pushback against discarding at the time, and there are definitely what you want to do is reduce bycatch. that's a slightly different issue, but if you are landing that stuff, you are still having an impact on the ecosystem. What people in the public discourse were seeing were images of fish that were being thrown back dead and thinking that that was a tragedy and useless, but it's dinner for something else. So that's why these sorts of modeling studies are important to conduct.
Thanks, Jack. And maybe Nana, you'd like to talk about if you had any experience with engagement with policymakers from the results that you got from the using the app. Nana, can you muted?
Yeah, hello, can you hear me?
Yes.
Yes, I was saying that for what I presented, we're looking at how to use the app, the StrathE2E, in helping improve our ecosystem since it is really connected within the coastal area. It's a coastal wetland and fishing, oyster, crabs are being taken. So whatever happens one way or the other affects the wetlands, which is a coastal wetland. So we're looking at using those apps to be able to determine the future happenings that will occur within the site. So I'm sure once we are able to run such a system, we can be able to inform policymakers on the zoning of the sites, because the sites are they have the sites are being zoned for core area, buffer zone, transitional zone, and things. So I'm sure this will improve on how policies are done, because it will be a data that will be able to predict or give a what if in case this happenings occur for this number of years, or the the number of fishing is reducing, or this fishing that we are getting, these types are reducing. What is causing it? So this will serve as a real time data to be able to inform a lot of policies that will be
Mhm.
done within those sites. So I'm sure policymakers would love it once you are giving them what will happen in the next 5 years or 10 years if whatever is happening now increases or it still remains the same.
Okay, thanks, Tana. I look forward to know more about your activities later on. So we have uh, another two questions. One from Irene. What kind of input data does StrathE2E use? Biomass of functional groups, trophic metrics, other parameters?
Sure. So we're getting into some of the more technical
Technical.
modeling bits here, but I'm happy to do that. So it doesn't take inputs in terms of biomasses. Those are importantly emergent properties of the model. So that's in contrast rather to something like EcoPath with EcoSim, if you're familiar with it. We're not trying to explain a known biomass. We're looking to see what comes out from base principles, from a mechanistic model. So what we do have are environmental drivers. So we have a seasonal cycle of things such as temperatures and nutrient concentrations at the model boundary, the exchanges of water masses between external borders and volumes of water mass inside the model. However, as well as those drivers, what we need to have are a collection of parameters which specify things such as the maximum uptake rates and the half saturation coefficients of the density dependent predator prey relationships within the food web. Now, what's nice is because of the way that StrathE2E runs, we actually fit a lot of those parameters to target data. So you need the drivers, you need to have data that advises on what the parameterization of the fishing fleet should be. So things such as activity rates, catches, discard rates, that sort of thing. But when it comes to estimating those predator-prey linkages, including the prey preference matrix, so that's the sort of trophic matrix you might have been suggesting, that's all fitted according to target data. And that target data could be any output from the model that we're able to then compare field observations to our model output. So at the moment, that includes regenerating the known fisheries statistics, but we also include things such as estimates of what the production to biomass ratios may be of different gills inside the model, what the production rates are of the different gills in the model as well, because we're able to have primary production and other production values in the model as an emergent outcome. They're not specified as a boundary condition, unlike something like EcoPath. So once you have that target data, we launch a simulated annealing process. It estimates what the parameters are most likely to be, and that allows us to also incorporate uncertainty estimates around the outputs and those distributions of the parameters, which is a nice additional thing which can be used for stakeholders because it gives us an expression of risk. And there's a long document that tells you how you might go and collect a bunch of those numbers and what there are. But there's about 500 parameters and drivers required to build one of these models. And in instances where we lack some of the data for a region, we do sometimes borrow parameters from nearby similar regions and treat those as subject to some uncertainty. But that's how modeling works.
Thanks, Jack. And there's another question for you on the technical part. Um, excuse me. Are there any socioeconomic variables included in the model, as this might help policymakers? And for example, if you decrease a particular fishery stake, it may increase unemployment and household income of X households and increase poaching, etc.
Sure. So at the moment, the model runs in terms of the biomasses of the elements of the food web, but also the recorded landings that are being extracted by the different fishing fleets. What you can do is you can convert using prices that biomass into a value of the landed catch. What's more interesting is to try and actually engage in some of the economic modeling directly. So this is work that's currently under progress and it hasn't been published just yet. But we do have a draft bioeconomic model where the fishing fleet reacts dynamically in the system to the profitability of fishing. So what that means is that we've adjusted the models such that there are fixed costs for employment on the fishing vessels, and there are variable costs in terms of things such as fuel. And we end up calculating what the equilibrium point is in terms of what the amount of money made by landing the fish is in response to the operating costs of that vessel in the model. And then what we actually end up being able to include is a sort of exit rate where the fishing fleet will self control, and that if it stops being profitable, some vessels will exit and the fishery will shrink. And you can use that to infer on what might be the increases in unemployment or household income if you know that a third of your vessels have left the system because it stops being profitable given a certain degree of production in the fishery, but also hypothetical costs in terms of fuel and wages. That's not a fully closed economic system because, of course, there's the whole supply and demand aspects of pricing in fish, but you have to go and talk to some other people about how you'd want to parameterize that relationship because ultimately I'm a marine ecologist rather than an economist. But there's certainly interesting information to include, and we're making headway onto that at the moment.
Thank you, Jack. And now Luis Fernandez has another question. Can we feed the model with specific species within the guilds to apply scientific policies?
So it's not a species specific model by design. So we are thinking about making it a more flexible model that allows you to incorporate like maybe one additional species or something if it's of high interest. But the issue is that when you make these things species level, it ends up then becoming a very high dimensional problem, and you can't answer some of the cool routines we can do at the moment. So obviously you can't do it with the app because you spend a long time clicking on sliders. But for those who can code, we can do full global sensitivity analyses across the different fishing parameters, for example, and quantify the interactions between different fisheries for the purposes of ecosystem-based fisheries management. If you go from 26 functional groups up to 30 or 40, that complexity of the analysis increases exponentially. So it gets away from some of the goals of a lightweight model like this to be able to look into some of those strategic trade-off type questions and the uncertainty quantification that aren't available to more complicated species level analyses. That doesn't mean you can't hack it. So we have been known, I mean, some of the guilds in some locations are essentially monotypic. So it may well be that your migratory fish guild is parameterized to just be tuna, in which case you can talk about a rather specific part of the food web. If you parameterize a guild with a specific species or a small collection of species in mind. Similarly, we have a polar version of the model, and we have a maritime mammals guild, but that's essentially polar bears. That's what we mean. So for some of these guilds, there is not much diversity in there. But if we're talking about a guild such as the benthic suspension and deposit feeders, that's massive. That's all the weird things on the seafloor that filter feed. So that's a harder one to be able to have a species specific conversation. What you could do is you could end up adjusting, assigning sort of proportions of the biomass or something for a rough and ready estimate of, I know that I only harvest 10% of the demersal fish, and that's just the cod. You can try and do something like that with your scenarios, but it is not the purpose of the model to give species specific advice.
Thank you, Jack. And thank you so much for for so many questions. And Irene has a question for Nana. What are the major challenges of applying StrathE2E to such complex systems? Nana, I see that you're still muted.
Okay, thank you for the question. As I said earlier on, we are yet to apply the challenge will be you have to specify. You can't lump all what you want to see within. So you have to select certain parameters to be able to run the scenario. I'm not sure it's going to be able to run every mishappening within the sites that you have. So it's going to be a selection of maybe few dominant ones to be able to run such a system. So that's what I think for now. Thank you.
Thank you, Nana, and thank you, Irene, for the question. Um, so we don't have any questions now. Jack or Nana, would you like to say anything or share anything with the audience?
I can just reiterate that if people are interested in using the tool themselves, whether it's from a teaching perspective and you want to be able to use this to illustrate some core fisheries or conservation concepts, and I'm very happy to take emails and to talk to you both about programming in R with the R package or using the app for something that's a bit lightweight. Similarly, if any of you are more in the kind of professional practice area and you're interested in that conversation about how do we involve stakeholders in a participatory modeling way, so not just going, here's my model, it says this, please do it, but instead going, here's the model, what happens if instead we actually run through those simulations together and try and find in partnership what the outcomes might be and how we could perhaps adjust things because we don't like what the outcomes of one are or the other. I'm also happy to have those more kind of conceptual conversations as well and establish a way of improving that connection between the sort of mathematicians and statisticians hiding in a Scottish maths department versus the stakeholders who are doing things to improve the future for our oceans, because ultimately that's the thing that I'm excited about doing. So any way we can help would be great.
Thank you, Jack. Nana, would you like to share anything before we close the session?
Okay, thank you so much, Tiana. I would like to thank Mission Atlantic and thank Dr. Jack for giving us the time to also express what we think the StrathE2E can be used for. I think in further discussion, I'll try and contact Dr. Jack and we'll see how best to use it within the settings of a coastal wetlands. So thank you.
Yeah, and thanks for sharing your perspectives for Ghana, Nana, and thank you, Tanya, for organising all of this and keeping us to time.
Yeah, thanks. Thank you both to participate. And thank you to everyone who joined us. I hope it was really helpful for you, and please reach out. Okay, well, thank you, everyone. Have a nice rest of the day.
Thanks. Bye.
Bye.